Okay. So today we are going to be doing a DNA replication lab. As you can see, we have some candy out, and we're going to make DNA with them, and then we're going to replicate it. So first off, we have your DNA replication notes. These are mine. These are all filled in. So I'm going to go over these really quickly with you before we begin the lab. So first off, a blank molecule of DNA is the original to be blanked. So a parent molecule of DNA is the original to be replicated. All right, so that's when the DNA molecule starts out. It starts out completely formed, as our picture shows here. Our picture shows here that it's completely formed. Nothing's happened to it yet. All right, the second step is an enzyme called helicase. Helicase. It comes in to unzip. It unzips and separates the two strands of the DNA. It is called helicase because it unzips the double helix. So now our one double helix has been unzipped to become two. All right, after it becomes unzipped, each strand can be used as a template. To make a new strand, it may be used as a template to make a new strand. If a single strand has an adenine, it would pair with a thymine. And if it has a guanine, it would pair with a
cytosine.
Good job. All right, the enzyme that joins the new bases is called DNA polymerase. DNA polymerase. Remember, poly means many. So DNA polymerase comes through and attaches new nucleotides to each side of the strand. So by the end, DNA polymerase, at the last one, DNA polymerase checks and fixes any errors it finds. All right? We now have two complete strands, each identical to our original parent strand, but it is combined with one parent strand and one daughter strand. So on your picture, mine's blue and gray, mine's gray and white. The blue one is part of your parent strand, and the white one is your new daughter strand. All right, so what we're gonna do is we're gonna start with making a candy model of our DNA. So I gave y'all all instructions, and so what you're gonna do is you're gonna take 2 pieces of your red licorice, and you're going to assemble the DNA in the nucleotide sequence ATCG. All right. So each of the gummy bears that we have represents a specific nucleotide. So yellow is adenine. Orange is going to be our thymine. Green is cytosine. And your pink, in this case red gummy bears, is going to be guanine. So ACTG, what color are you going to put first?
Yellow.
All right, so just yellow?
No.
No, yellow first.
Yellow and then orange.
Mm-hmm.
And then I'm going to put...
You just got to impale them.
Yeah, I'm trying.
Why don't somebody else help her build this so that it's not just mom doing the work?
What's next?
All right, you guys
Or
discuss.
What's next in the strand?
should be a green and then a pink.
And then after that, T and A. What
I will
color
check
is
it
T and what
after
color
we all
is
get it
A?
together.
Well, it's
Is this the one we're building here?
No, it's going to be ATCG.
Oh, it's just 4?
C is.
And then you have to build a full model of your DNA.
isn't it another strand that we need to put
Oh,
together?
I see what we're doing.
Yeah,
I see.
that's
Yeah.
what I'm
Hold on.
saying. It's
Yeah,
I
you're
need
putting-
another
you
cube.
need it right.
There you go.
Well,
The bad thing is these don't have 2 pokies, so you got a
Oh.
green
well,
one.
okay. This is going to have to be built slowly.
Okay.
We're just going to
4
pretend
minutes.
that's attached. Yellow and pink. Which one's? Oh, pink.
Red.
Would be next, correct?
I will check it when y'all are done.
And then it's
T
the opposite.
is thymine. I mean orange.
And yellow.
And a yellow.
And then opposite is red.
Hold on.
We'll put that in there and we're going to pretend that's over there.
That's a good plan.
There's your red. Then green.
Do you want me to continue?
Nope, just those 4. So I'm going to check it. So we had A, which is a yellow gummy bear, and it should be attached to T, which is orange. Good job. Then it was T. So A and T,
And then
And
it was
and then it should be A. So
No.
this is only one side of our DNA. So you guys have to also make sure, so this would be 1/2.
Is this the other half? Like this?
No.
Okay.
So this one is correct.
Uh-huh.
So ATCG only refers
To the first one.
to 1/2. So you
Yeah,
have to also make sure you have the
So for
complementary
T,
side.
it'd be the exact opposite of the first one.
Okay,
It
so
would be
it'd
like
be-
that. A-T.
What's
C.
this?
No.
no, it's
Blue.
got the
A-T. A-T. Which one's C? What color?
C is green.
Okay.
C. There.
There you go. So that is going to be our parent DNA strand. It's okay if they don't connect.
We're pretending.
We're pretending on this one. That's okay. If it goes off, I can just,
Okay, hit the button again.
yeah, just hit the button again. And then I'll
Okay.
combine it.
Alright.
Alright, so after we do that, so we have our parent strand. Now we need it to replicate. What happens when something replicated? Where it replicates? Refer to your notes.
Splits.
It
Splits.
splits.
It
So it
unzippers.
uses helicase to
Zip
unzip
it.
the genes down the middle.
So they go down here. So what I would have be a yellow.
Be a yellow on one.
Yellow. And an orange on one side. And a green. A green and a red.
And that's one
Okay?
side.
That's one side. That's the parent. And the daughter would come back and be orange, yellow, red, and green to be the daughter.
Correct. So walk me through what happened.
It unzipped it and then it paired up
Okay, yeah.
and made another strand of DNA.
Alright. So just for this, we're going to put these down so they're our
Our-
backbone.
Okay.
Alright, and so now what do you have?
I have 2 strands of DNA.
You do. They're 2 strands of DNA, they're composed of a
parent.
parent
And a daughter.
and a daughter. Alright, good job. So what enzyme laid down the new Nuclear polymerase. Correct.
Polymerase.
Good job. All right. With this, there's also a set of questions that would go with this lab. For this purpose, we're not actually going to be doing them, but they are very good questions for a whole group to answer. Why is it necessary for DNA replication to occur? How are your original strands new? How are they different? It also has where you would go through and you would label your, there we go. It also has this nice little sheet where you go through and you label what you did, telling them what colors it would be. If you decided to use, like we did here, we decided to use 2 red licorice sticks instead of using 1 black and 1 red. And this one also has how is your original and new strands similar. So I believe that this is a really great group activity where you can step back and really let the students do the work mostly for themselves. Obviously this was a little different. I had to step in to help a lot. I would have had a longer time to do a better lecture before we did these, and this would be more of a review. Thank you, and that is all.